April 2025. The world's top news agencies seem to have gone mad. Everyone's forgotten about politics and is buzzing about some planet. Somewhere out there, far away, scientists might have found life.
Signs yet of extraterrestrial life.
Skeptics rolled their eyes. We've heard this before, but this time it felt different. Too confident. Too loud. Too convincing. K2-18b. Suddenly, everyone knew the name. Physicists, bloggers, politicians are all talking about it. Today, you'll find out why it's better to have no skeleton on some planets, what another habitable planet might smell like, how scientists managed to sniff the atmosphere of a distant world, and most importantly, is there life on exoplanet K2-18b? 1998. The story begins with the discovery of an unremarkable star, a small, dim red dwarf in the constellation Leo, located 124 light-years away from us. It's 200 times dimmer than our Sun, nearly twice as cool, and only a third as massive. 2003. This star is simply added to an astronomical catalog. No fanfare, no public interest. 2015. During its second extended K2 mission, the Kepler Space Telescope starts observing the red dwarf more closely. Suddenly, a transit is detected. This is when the light from a star is briefly blocked by something. A planet. By then, Kepler had already discovered many exoplanets, so while it was a nice find, it wasn't exactly groundbreaking. The planet was named K2-18b, the 18th planet discovered during the K2 mission. Little did anyone know this unassuming catalog name would later break news headlines and become a huge sensation. At first, there seemed to be nothing special about the planet. It's 8.6 times more massive than Earth and 2.6 times larger. It orbits its star in what's called tidal locking, always showing the same side to the star, just like the Moon does to Earth. This is typical for planets orbiting red dwarfs. One complete orbit around the star takes 33 Earth days. The planet itself is something in between a dense rocky super-Earth and a mini Neptune. In other words, it isn't exactly clear whether it has a solid surface. Is it made of gas or something else entirely? At first, scientists simply couldn't say for sure. Overall, this was interesting, but not sensational. But the more it was studied, the more surprising it became. It turned out the planet orbits within its star's habitable zone, the region where water could potentially exist in liquid form on the surface, not boil away, not freeze, but simply exist, just like on Earth. In astronomy, this is also known as the Goldilocks zone, named after the fairy tale where the girl tastes porridge that's too hot, too cold, and then finally finds one that's just right. It turns out, this planet might be just right, at least when it comes to liquid water. Now, the question arises, if the star is the stove and the planet is like a pot sitting on a hot burner and the water isn't boiling away, could something actually be cooking inside? By that time, K2-18b was already interesting, but now it's becoming suspiciously interesting. 2019, another piece of the puzzle. Scientists are analyzing the planet's composition and suddenly notice there's water vapor in the atmosphere. Not just maybe there's water down there, maybe not, but actual moisture high in the air. This means it's not only warm, it's humid, and if it's warm and humid, then possibly it rains there. How do they find this out? When the planet passes in front of its star, some of the star's light filters through the planet's atmosphere. Telescopes like Hubble and later James Webb detect this tiny difference in the light spectrum. This method is called spectroscopy. Special spectrographs aboard Webb read the composition of the atmosphere, like molecular fingerprints. And water vapor leaves a very distinct fingerprint. Now, this is no longer just interesting. It's absolutely thrilling. A planet in the habitable zone with an atmosphere, and in that atmosphere, there's water. Now, the question is, what else is in that atmosphere, and what's beneath it? When astronomers began modeling the atmosphere of K2-18b, they realized it was a very unique cocktail: hydrogen, helium, and water vapor. and there might be enough vapor to form clouds. Just think about it, another planet with liquid water and clouds. And this is almost a confirmed fact. But if there are clouds above, what's below? Scientists couldn't shake the feeling that this planet didn't quite fit into established classifications. They had to admit they were looking at an entirely new class of planets. Researchers called it Hycean, from hydrogen and ocean. In other words, an oceanic planet surrounded by a hydrogen-rich atmosphere, not just one with seas and continents like Earth, but one completely covered in water, thousands of miles without a single patch of land, and beneath, there's only an abyss, dark, cold, and full of mystery. Why does this matter? The issue isn't just that K2-18b belongs to a mysterious class of planets, it's that we may have just discovered an entirely new class of worlds. It's neither a super-Earth nor a mini-Neptune. Its atmosphere is too thick, and we don't know anything about its surface. The term reflects its hybrid nature, as it's a planet that's fully covered by oceans and surrounded by hydrogen atmosphere. Sounds odd? That's because it is. Hydrogen is the lightest gas, and it's nearly absent in Earth's atmosphere. It escapes too quickly, but on more massive planets like K2-18b, hydrogen can be retained for billions of years. This means liquid water plus a hydrogen atmosphere? Why not? What does this realization offer? First, a hydrogen-rich atmosphere allows infrared light, the primary energy output of red dwarf stars, to easily pass through. Second, it helps trap heat. That's another key piece of the puzzle. Even if a red dwarf gives off 200 times less light and heat than our sun, a Hycean planet could still receive enough energy to maintain a warm ocean under a perpetual twilight. The twist? Until recently, scientists considered planets like these unlikely candidates for life. Hydrogen? Too reactive. Pressure? Too extreme. But then researchers ran new calculations, and the James Webb Space Telescope delivered new data, and they found exactly the opposite. Hycean planets might actually be the most common potentially habitable worlds in the galaxy. They may offer ideal conditions for life, especially if the ocean is warm, salty, and has a steady energy source from below. And just as important, they're easier to study with telescopes, which means we'll likely get more data on Hycean planets than any other kind. And if K2-18b really is a Hycean world, then right now, someone might be living deep within its waters. But how can we possibly find out from so far away? 2023, the first cautious answers begin to arrive from the James Webb Space Telescope, the leading cosmic detective of our time. The atmosphere of K2-18b is in its line of sight. Webb directs both of its ultra-sensitive spectrographs at it, and here's what it finds: carbon dioxide, methane. But one thing is almost entirely missing: ammonia. You might think, what's the big deal? But here's where it gets interesting. This specific combination, methane plus CO2 without ammonia, might indicate an ocean of liquid water, hidden beneath layers of gas. As for methane, it's a typical byproduct of organic decomposition on Earth. Could the same be happening on that planet? Of course, methane alone doesn't prove anything. It can also be produced through non-biological processes, but it's another clue that tips the scale toward potential habitability. It's still not life, but it's the kind of environment where life could exist. Then, scientists took a closer look at the data and said, something's off. It's too perfect. Water, clouds, a warm ocean, and now gases that on Earth are often linked to biology. So far, it's all indirect. For now, it's just a model, but you can already smell the sensation in the air, and it wasn't long before that sensation arrived. 2025. The James Webb Telescope turned its eye back to K2-18b, but this time with focus, with seriousness. No more surveys or reconnaissance. This is a full-scale scientific operation. The researchers want to answer one simple question: what if all of this is true? And then a discovery. Something that no one expected appears in the atmospheric spectrum: dimethyl sulfide, DMS, and possibly dimethyl disulfide, DMDS. What are these substances? More importantly, where do they come from? On Earth, these compounds are produced only by living organisms, marine phytoplankton, bacteria. No volcano, no non-living chemistry can create them. Hold on, let me say that again. Science doesn't know any other way these substances are produced, only biological. By the way, here's something interesting. On Earth, some of the dimethyl sulfide produced by plankton rises into the atmosphere and turns into microscopic sulfuric acid particles. These, in turn, contribute to cloud formation. Scientists examine the data. They double-check. They suspect an error. Everything checks out. DMS is definitely present, and the concentration of DMS and DMDS in K2-18b's atmosphere is more than 20 times higher than on Earth. Just so you know, dimethyl sulfide is what creates that distinctive smell of the sea. Imagine what it must smell like on K2-18b. So, does it all add up? Have scientists discovered a planet with an ocean teeming with life? Well, it's not that simple. This is where things get really complicated, because science isn't about wow, it's about hold on, let me check that out. DMS in the atmosphere? Yes, that's true. But could it appear without life, at least in theory, even with a minuscule probability? Some scientists believe, theoretically, yes. For example, in an atmosphere with extreme pressure, high temperature, and unusual chemistry, DMS might be a byproduct of non-biological reactions. Suppose something hot rises from the planet's interior, reacts with other compounds, and there you have it, DMS. Rare, complex, but possible. We can't be certain that the processes there are exactly the same as on Earth. Until we have some evidence, we should consider abiotic scenarios. Is that fair? Absolutely. Is it disappointing? Just a little, because there are still plenty of optimistic scientists who make a strong case. Our ultimate goal is the identification of life on a habitable exoplanet, which would transform our understanding of our place in the universe, says Professor Niku Madhusudhan of the University of Cambridge, lead author of the study. Our findings are a promising step towards a deeper understanding of Hycean worlds in this quest. Alright, you'll soon get a glimpse of what life might look like on this planet. But first, let's explore what this world feels like from the inside, what it's actually like to be there. Imagine you're an astronaut stepping onto K2-18b in an ultra-durable yet flexible spacesuit, one that lets you fully sense your surroundings, sights, sounds, even smells. What would be your first impression? Something feels off. Not just because you're on another planet, but because everything is slow and thick. The air here doesn't feel like air at all, more like a dense, almost tangible gas, thick as fog. It presses in from all sides, and sounds come through it muffled and deep, much like what you'd hear underwater. The sky? Not blue, not even red, more like a dusty darkness, scattered with reddish light, something like the murkiest sunset you've ever seen. Visibility is low, light is scarce, everything is bathed in a warm half-darkness. The ocean doesn't sparkle or roar with towering foamy waves. Instead, it just rolls, thick and slow, like molten oil or tar. The water itself has about the same density as Earth's oceans, but the dense, high-pressure atmosphere makes every wave heavy and sluggish. And it probably smells like the sea. A very strange alien sea, but the sea nonetheless. And somewhere in that silence, in that warm, viscous water, there might be something alive, just not according to our rules. What kind of life is it? What is it made of? What does it look like? Does it resemble Earth's creatures with legs or tentacles, eyes and teeth? Or is it some kind of slime? Or something entirely incomprehensible? First of all, there are most probably no cities there. If you're looking for little green men, this probably isn't the place. On a planet with gravity 2.5 times that of Earth, a dense hydrogen atmosphere, and intense pressure, everything would likely have to be tiny, small, and most likely single-celled. Here on Earth, we have microorganisms that live in acid, in boiling water, under miles of water, in radiation. So what's stopping something like that from surviving out there, in the endless depths of an alien ocean? At the bottom of Earth's oceans, there are black smokers, hydrothermal vents. Clouds of sulfur, iron, and some other materials shoot up from these vents. Around them, there are living colonies of bacteria, entire worlds of microbes that draw energy not from sunlight, but from chemicals. This is called chemosynthesis, and it may be the key to life that doesn't rely on photosynthesis, as we see in plants, because red dwarfs don't give off much light. Most of it is in the infrared part of the spectrum. But even with that kind of limited light, some Earth organisms still manage to survive. For example, cyanobacteria. And what if it's not just single-celled life? Could there be something bigger there? Well, at the very least, it's not impossible, but there are some caveats. The existence of small multicellular life forms like worms is entirely plausible in such extreme conditions. On Earth, similar creatures live around the very same black smokers, deep under the ocean. They feed on chemosynthetic bacteria or even enter into symbiotic relationships with them. They survive without oxygen, without light, in boiling water. That's already more interesting, but what about something more complex and larger than worms? It's quite possible there could be living organisms in such environments, with bodies made of dense gels or gelatinous tissues. At high pressure, a rigid skeleton becomes a disadvantage. So any life form in such an environment would likely be soft but springy, like deep-sea cephalopods or jellyfish. Once again, we have no idea what their biology would be like, whether they have something resembling DNA or something else entirely. But at least the laws of physics and chemistry don't forbid such creatures from existing on K2-18b. Okay, but how would they communicate or hunt in such a place? In an infrared-dominated environment, normal vision might be replaced by thermal one, or by sensitivity to even the faintest electrical currents. Earth's eels, rays, and sharks already have these kinds of superpowers. They can literally feel water's chemical composition and electrical currents through their skin. And finally, bioluminescence. Local organisms would almost certainly have it. Glowing in the dark is a way to communicate, to find food, or to show off, especially if they reproduce sexually. Put all of this together, and you'll get a vast ocean planet, shimmering with light like a giant living garland. But how feasible is all this? It's hard to say. As we've already mentioned, high pressure doesn't promote the growth of large organisms. Just look at Earth's deep ocean. The deeper you go, the smaller life tends to be. And as for K2-18b, we still have far too little information. In any case, if it were confirmed that even single-celled life existed on K2-18b, it would be one of the most important discoveries in human history. It's a bit frightening to realize, but from that moment on, we would no longer be alone in the universe.